Yep. 2 over 3 brackets 4 brackets the power of 3 over 2. We get 16 over 3 for this first one. So 16 thirds minus, and if we just go straight back up and replace it with a 1, 2 thirds. Nice and easy. 14 thirds. Same thing to apply over here. If we just replace this, we'd have 2 thirds times 4 times the square root of 4 minus 2 thirds 1 times the square root of 1. And we should still get that same answer of 16 thirds minus 2 thirds, which is equal to 14 thirds. Really important that you can do it either way. This way here, there's nothing wrong with doing this. Some people like to rearrange it so it makes it a little bit easier to look a little bit neater, but you're going to get that same answer either way. Alrighty, let's have a look at the third example. We're going to get into some trig here. So remember, whenever we're working with trigonometry, the first thing you want to do is make sure your calculator is in radians. Okay. Second thing is get your brain thinking about that unit circle. So let's have a look at this here. So we got pi on 2 0 sine dx. Alright, so when we're looking at this question here, first thing we're going to look at is, well, we've got to remember what is the integral of sine dx. And of course it's going to be cos dx. However, I'm going to change this up a little bit. 2x dx. Let's put the 2 in there. Just so that way we've got a little bit more to play with. Okay? Alright, so let's integrate this. Remember when we're integrating a trig function that has a value greater than 1 for the x? That has to be brought out as a fraction. So we can rewrite this here as half cos 2x, and then we can write our values in terms of pi on 2 and 0. So what we can look in this here, oh, I get negative. Hope you caught me on that one. So negative cos. What I can do here is, I'm not really dealing with this half here. I can come back and look at this rule and say, well, let's bring that negative half out and only substitute in for our pi on 2 and 0 for x. So what we would have here is cos 2 pi on 2 minus cos 0. Now, if we think about our unit circle in this case here, cos 2 pi on 2, well, these two would cancel out, so I'll just get cos pi. And cos pi, when we think of our unit circle, remember here we've got 0, 1, whoop, we've got negative 1 and 0 and negative 1. Okay, what else have we got? We've got x equals 1 and 0, so x equals 0, 1, x equals negative 1 and 0, and x equals here 0 and negative 1. Cos 2 pi will bring me up here, but because I'm doing 2 times pi on 2, these are going to cancel out, I get pi. So therefore, I'm all the way over in this section. And if I'm looking at this correctly, I should end up with negative 1 for x. Because remember, cos and sine. So cos is your x value, sine is your y value. So if we look at this instance here, and we also look at cos 0, well, cos is going to be 1. So we end up with negative half, brackets, negative 1 minus negative 1. Remember, it's always that minus up here. Don't get caught with that. So therefore, we end up with negative half minus 1 plus 1 is going to give you 0. Oh, sorry. It's going to give you 1. Yeah. So what we get out for our answer here is we get 1. So our final answer in this case here is, we'll get that, yeah. We get that answer of, because that was 1, not negative 1, sorry, negative 2. So therefore, negative half times negative 2 gives you 1. Alright, let's look at one last example, and then that will be it. So this last example here looks a little bit difficult. However, what have we got? 2 pi on 3 and 0. So we've got sec squared half theta d theta in terms of theta. Alrighty. Here we know sec squared is written as 1 cos squared x, which here is the same as tan x. So if sec squared x is equivalent to 1 over cos squared x, then we know that if we integrate that, we're going to get tan x. So the integral of 1 over cos squared x, same as the integral of sec squared x, will give me tan x. So what we're going to do here is, let's work that out. So we're going to get 1 over 1 tan, we're dealing with theta here, or tan half theta. Okay? So let's now fix this up between 2 pi on 3 and 0. Well, we know that we can pull this number out again, just like we did with the previous one, but we're going to fix this up. 1 divided by 1 on 2, well, the reciprocal of that's going to be 2. So we can get 2, bring it out the front, and then put in tan half, and let's plug all this stuff in for theta. 2 pi on 3 minus tan half times 0. If we continue this process, what we're going to get is, we can simplify this down. We will get 2. Well, half, so 2 times 3 is 6, so we get 2 pi on 6, which is the same as pi on 3. Well, my texter is running out, so pi on 3 minus 0. Okay? So when we're looking at this case here, 10 pi on 3, can you remember that? That should give you root 3 minus 0. So our final answer would be 2 times root 3. So when we're looking at these types of questions, really important that we remember to integrate correctly. Remember that little key that we can pull the information out. We're not integrating the constant, we're integrating the function. So therefore we can then multiply that constant back in. Definite integrals leads us to finding the area underneath a curve, which we're going to look at next. Exactly the same process as when we do indefinite integrals in terms of integrating, except this time we've got those upper and lower bounds. So we follow this process. Here's your integral. We integrate it in terms of upper and lower bounds, and then we find the difference between those upper bounds. See you in that next one.